Good morning. In this video, we are going to continue with chapter 3, pair of linear equations in two variables. So we already know the general form of it, which is a1x plus b1y plus c1 equal to 0 and a2x plus b2y plus c2 equal to 0, where a1, b1, c1, a2, b2, c2 are all real numbers and a1, b1, a2, b2 all should not be 0 at the same time. We have also seen that for the solution of a pair of linear equations in two variables, there are two methods, graphical method and algebraic method. In this video, we are going to see algebraic method for solving linear pair of equations by using substitution method. So for this method, the first step is finding the value of one variable, say y, in terms of the other variable, say x, from either equation, whichever is convenient. Then that for the next step, we'll substitute this value of y in the other equation and reduce it to an equation in one variable, that is in terms of x, which can be solved. The final step is substituting the value of x or y obtained in step 2 in the equation used in step 1 to obtain the value of the other variable. So only 3 steps involved. We are going to write one variable in terms of the other, then substitute, solve for one variable, then substitute back again to solve for the next variable. Let us move on to exercise 3.3 to understand the method better. First question, we have to solve the pair of equations by substitution method. X plus y equal to 14 and x minus y equal to 4. So first we will take these two equations and number them as 1 and 2. Then from equation 1, we obtain that x equal to 14 minus y. We can either substitute for x or y, that is up to us. Now substituting this value of equation 3 in equation 2, we'll obtain, instead of x, we are going to write 14 minus y equal to 4. So when we solve it, we get 14 minus 2y is 4, which is 10 equal to 2y, y is equal to 5. So we got the solution for one variable. This value will substitute in equation number 3. So then x is equal to 14 minus y, which is 14 minus 5, 9. So we got x as 9 and y as 5. So we got the solution for these pair of equations using substitution method. So here we'll have to substitute two times from one question. From equation 1, we are getting a value which will substitute in 2. We'll get an answer again substituting in 3. So twice we'll have the substitution. Now the second part is in decimal. 0.2x plus 0.3y equal to 1.3. 0.4x plus 0.5y equal to 2.3. Any real number can be solved using this method. So is decimal form. So first we'll number the equations 1 and 2. Then from equation 1 we obtain x is equal to 1.3 minus 0.3y divided by 0.2. Yes, it looks a little bit complicated, but it's okay. This we will mark as equation number 3. Now substituting this value in equation 2. So our first substitution over here. So 0.4, instead of x, we are going to write the right hand side of equation 3, which is 1.3 minus 0.3y divided by 0.2 minus, continue with the first one, 0.5y equal to 2.3, which is 0.4 into this. Then 0.2 will take LCM throughout. We'll solve it to get y is equal to 3. Substituting this value in equation 3, we obtain x is equal to, we'll substitute the value of y to be 3 over here. So solving, we get x to be 2. So x is 2, y is 3 is the solution. Moving on to the third one, I told you it can be solved, all the real numbers can be solved in this method. We are using irrational numbers. Root 2x plus root 3y equal to 0. Root 3x minus root 8y equal to 0. As usual, the first step we will number the equations 1 and 2. From equation 1, we'll substitute x is equal to This is 0 on the right side, so it will be minus 3y divided by root 2. Now substituting this value in equation 2, we obtain root 3 into minus root 3y by root 2 minus root 8y equal to 0. So which is root 3 into root 3 will be 3 for us. So 3y by root 2 minus 2 root 2 y equal to 0. We are factorizing this, so we get 2 root 2. Now here y we can take common out. We have to find the value of y into minus 3 by root 2 minus 2 root 2 equal to 0. Now either of this should be equal to 0. We know that constants cannot be 0. So therefore y has to be equal to 0, which is equation number 4. We'll substitute this value in equation 3. This is the second substitution. We get x also as 0 because root 3 y by root 2. Y is 0, so x is also 0. X is 0, y is 0. That is, origin is the solution for this set of equations. Now we move on to fraction type of question. So we have 3x by 2 minus 5y by 3 equal to minus 2. X by 3 plus y by 2 equal to 13 by 6. So first we number the equations 1 and 2. Now fractions are a little bit complicated, so we'll convert them as normal equations taking the LCM, which will be 9x minus 10y equal to minus 12 because LCM will be 6 over here. Then we substitute for x equal to minus 12 plus 10y divided by 9, which is a equation number 3 after getting the value of x. Now we are going to substitute the first substitution in equation 2. So we get minus 12 plus 10y by 9 divided by 3. So instead of x we have substituted plus y by 2 equal to 13 by 6. Again we'll take LCM over here. LCM is 6. So we multiply and then solve. We get 47y equal to 117 plus 24, which is 47y equal to 141. So y is 3, which is equation number 4 for us. Substituting this value in equation 3, we obtain x as minus 12 plus 10 into 3 by 9, which is 18 by 9, so 2. So hence we have x as 2 and y as 3. So whether it be decimal form or irrational numbers or fractional numbers, any type of real numbers can be solved using this method. Now, the second question. Solve 2x plus 3y equal to 11 and 2x minus 4y equal to minus 24. So two equations are given to us, and hence find the value of m for which y is equal to mx plus 3. So first we have to solve these two equations. So we will get the value for x and y. We'll substitute that in this equation to get the value of m. So we have two parts in this question. So first let us number the linear equations. 2x plus 3y minus 11 will be equation 1. 2x minus 4y equal to minus 24 will be equation 2. Now from 1 we will take the value of x equal to 11 minus 3y by 2, which will be equation number 3. Then we move on to the first substitution. Substituting the value in equation 2, instead of x we are writing the value, then solving we get y as 5. Putting this value in equation 3, we obtain x as minus 2. So x is minus 2 and y is 5. Now that we have got the values, we have to substitute in the equation y equal to mx plus c. Y value is 5, x value is minus 2, c is 3. Now we have to find the value of m. So solving, we get m as minus 1. So we have solved both the parts of this question. Now moving on to the third question, which is a word problem type. Form the pair of linear equations for the following problems and find their solution by substitution method. So instead of directly giving the question, the equation, they have given a word problem. You have to form the linear equation. You have already formed this before, isn't it? You have formed for a single equation. Now we are going to form two linear equations and then solve by substitution method. Method is also mentioned in the question. Now, the taxi charges in a city consists of a fixed rate together with the charge for the distance covered. For a distance of 10 km, The charge paid is 105. For a journey of 15 kilometer, the charge paid is 155. What are the fixed charges and the charge per kilometer? How much does a person have to pay for traveling a distance of 25 kilometers? So let us take the fixed charge to be X and kilometer per kilometer charge to be Y. According to the information, first you're going to have a fixed charge, then for each kilometer you are going to have Y money, isn't it? So first is X plus 10 kilometer he's traveling. So 10 into Y is equal to he has paid 105 rupees. This is first equation. Now for that second person also, he has traveled first fixed money plus he has traveled 15 kilometers into Y, which is equal to 155 rupees in total. That will be the second equation. So let us solve this to find the value of X and Y. So from first equation, we get X is equal to 105 minus 10Y, which is equation 3. Substituting this in equation 2, we get 105 minus 10Y, which is the value of X, plus 15Y equal to 155. Solving, we get Y as 10. Putting this in equation 3, the second substitution, we get X is 105 minus 10 into 10, which is 100. So X is 5. So the fixed charge is 5 and charge per kilometer will be 10 rupees. First you have to give 5 rupees, then how much ever kilometers, that much into 10. Now for 25 kilometers, the second part of the question was how much he has to pay for 25 kilometers. So for 25, fixed charge plus 25 kilometers into per kilometer charge. So 5 plus 250, which will be 255 rupees will be charged. Now, the next part of the same type of question, a fraction becomes 9 by 11 if 2 is added to both the numerator and denominator. So a fraction means it will have numerator and denominator. If we are adding 2, both numerator and denominator, the fraction will become 9 by 11. The answer is 9 by 11. If 3 is added, then the fraction becomes 5 by 6. Find the fraction. So let the original fraction be x by y. Now numerator also 2 is added, denominator also 2 is added, then the fraction becomes 9 by 11. Let us cross multiply this so that we get the equation 11x minus 9y equal to minus 4, which will be the first equation for us. Now the second part of the question, we have to add 3 to the numerator and denominator and the fraction will become 5 by 6. So again cross multiplying and solving, we get 6x minus 5y equal to minus 3, which is equation number 2. Now from equation 1, we have to substitute x is equal to minus 4 plus 9y by 11. This equation 3 we are going to substitute in equation 2 for x. Solving, we get y as 9. Now this value of y will substitute back in equation 3. We get x as 7. So x is 7, y is 9. Don't stop it there. We have to find the fraction. So numerator by denominator form. The fraction is 7 by 9. The last step is very important. Okay, don't forget to write that. Now another part of the same type. 5 years hence, the age of Jacob will be 3 times that of his son. 5 years ago, Jacob's age was 7 times that of his son. What are their present ages? Let the age of Jacob be X and the age of his son be Y. According to the given information, X plus 5 equal to 3 into Y plus 5. Solving, we get X minus 3Y as 10, which will be the first equation. So the second part, 5 years ago, x minus 5 is equal to 7 times y minus 5. So we have the second equation, x minus 7y equal to minus 30. From 1, we get x is 3, y plus 10. Substituting in equation 2, the same procedure is being followed. We get y is equal to 10. Substituting this value in equation 3, we obtain x as 40. So we got y as 10 and x as 40. So Jacob's age is 40 years, whereas the present age of his son is 10 years. With this, we have come to the end of this video. We'll continue in the next video. Thank you.